Okay, great. I'll introduce you now. All right, so welcome back. So now we have Matthew Swindall, who is a PhD student at Middle Tennessee State University in the computational and data science program, and your final year as well. Yes, excellent. His research focus has been deep learning approaches for crowdsourced data sets. His team created the Aleph dataset consisting of many tightly cropped images of characters from ancient Greek papyri. And he is here to speak to us today on AI-assisted papyrology, integrating deep learning into the scholarly workflow. So Matthew, I'll allow you to take the floor now, and thank you.
Hello, everybody. Happy to be here to share my team's work with you. We are actually a partnership right now between Middle Tennessee State University and University of Kentucky. Fortunately, I'm not that well versed in papyrology myself. We have some people that help with that. My expertise is primarily with the machine learning data science side of it. But what we have done here is we wanted to, like the title says, integrate deep learning or AI into the scholarly workflow. In this case, it's in the form of AI-assisted papyrology. So my team has developed a pipeline. Now this pipeline spans back several years. I believe starting in 2010, the Ancient Lives Project opened up at over 12,000 fragment images from the Oxyrhynchus papyri collection to citizen scientists. Just anybody who wanted to could go on the web and annotate, locate different characters and tell us what they are. This resulted in millions of annotations, which we then use to create consensus annotations. So in general, these are majority rule consensus. So if 10 people annotated a character and said and 8 of them said it's an alpha, then we go with the majority on that. The next phase in the project is we took those consensus annotations and used them to create a data set. Now this data set is, we'll get to a little bit more in depth after this, but we have 2 versions, AL-all and AL-pub. AL-all, unfortunately, consists of some not publicly available fragments. So we released a smaller version that is purely based on entirely public domain images. So this data set, as well as these consensus annotations, we then use to train segmentation models and classification models. On top of that, we've also included a line finding algorithm. We're still currently exploring, trying to decide what best methodology to use here. We've used something called DBSCAN, but our most current iteration is using something called mean shift clustering. We'll get more into that down the road. But all of this together has helped us or enabled us to create an application prototype, which kind of as a placeholder name calling it Transcribe AI for now. I'm not sure what the final product will look like exactly. But as many of you know, documents from the ancient world are typically not in the best shape. However, most AI data sets, most AI models are trained on very pristine or even custom created data sets like the MNIST data set, which you see in the top of the middle. Documents from the ancient world are never that perfect, as you can see on these examples on the bottom, as well as this fragment from Oxyrhynchus on the right. They're typically littered with holes, rips, tears, faded ink. This typically, when you train an AI model on pristine data and then give it these types of images, they have a really hard time finding any characters. So, but the AL-all and AL-pub data set, we actually trained a few different models on this, kind of exploratory initially, but we found that surprisingly, and on the right, we actually see examples from the AL-all data set, or AL-pub, excuse me, public. We actually found that instances like this here, where you're missing parts of the character or parts are faded or ripped, have actually been helpful in training these models. Now, these 2 data sets, like I said before, the AL, the publicly available version, is over 205,000 characters. while the not publicly yet, hopefully we're working on that, is over 400,000 characters. So models trained on these do pretty well, surprisingly well. First, I'll talk about our segmentation model. For this, we tried something a little bit different. We're doing something called transfer learning, which is basically when we take a pre-existing model and we retool that model for a new use case. So for our trials, we used YOLO. I'm not sure if anybody's familiar with that. It's a pretty popular segmentation model, but it's primarily used for object detection. So you give it an image and it would tell you, there's a truck here, a bicycle there, a person here. So we retooled that model and trained it on 212 fragments of papyri images. Within those, there were 4,097 characters that were annotated from the Ancient Lives project. So we used those locations and annotations. In early trials, we actually tried to train for all 24 characters in the standard Greek alphabet, but we didn't have very good results. So what we did is instead, we trained for just one single class, just character, any kind of character. We didn't care what it was, we just wanted to find characters. So we split the training data into 80% training and 20% for validation and testing. What we found at the end was that we got precision of 0.88 and recall of 0.84. Now, for those who aren't that familiar with these terms, they're basically a little bit more robust way to look at how well the model does rather than just accuracy. So they're basically measures of the times that the model got things right versus the time the model doesn't. So and as you can see on the bottom right, this model does pretty well at finding where the characters are. We're looking right now at trying some different metrics. There's something called intersection over union that might actually be a better way for us to determine how well it's actually finding the characters. The second model we trained is a classification model. It's a standard convolutional neural network that uses something called a residual block, which typically is called ResNet. This was trained on the AL-all data set. Each of the images in AL-all consists of 70 pixel by 70 pixel images of individual characters, ideally individual characters. The model outputs probability for all 24 standard characters in the alphabet. So for instance, if you get a probability of 90% of gamma, for instance, that's most, and everything else is a lower probability, then it predicts that character is a gamma. So when we trained this model on AL-all, we ended up with training accuracy of nearly 97%. When we tested this on our validation data, we got an accuracy of 94%. So this model does surprisingly well at identifying characters. Again, neither of these models is perfect. They do extremely well, better than we expected. So the next thing we did was combine the two models. So each of these pairs you see here, on the left, we have a fragment that we gave the segmentation model, and the blue bounding boxes show the location of that character. And on the right, we have a zoomed in image of that character. And above that, you can see the prediction, what character it thinks it is, and the confidence of the model. Now, this is not, the confidence doesn't necessarily mean that the model got it right always. That's just how sure the model is. See, these are all some pretty good examples here, but this is a fairly pristine fragment compared to some of the others that we've worked with. So I won't go too much into this. This is more of the math guy on our team, but the line finding method that we're using right now is called mean shift segmentation. Basically what it does is, first off, it looks at all of the locations and in the vertical direction, and it uses a clustering method to kind of sort those out, try to figure out which ones belong to what line. This is a very difficult thing to do, and this is one of the things why we're still kind of working on it, is that it's not always perfect. Most of these methods typically rely on knowing how many clusters you have. So Generally, you would say, there's 5 lines on the image or in the text, then we need 5 clusters. Well, we can't always do that automatically. So, but this mean shift gets around that, and it works pretty well. Once it has clustered the data vertically, then it goes in and clusters and orders them from left to right. That way you can actually get lines and individual lines and characters in sequence. So here's a little bit of output from the line finding algorithm. So on the left, this is kind of a depiction of what it's trying to do here. It actually rotates, it tries to correct the alignment vertically. Still working on that a little bit. Sometimes it doesn't quite catch the lines, but as you can see, it does pretty well at finding individual lines and segmenting everything. We even have one little weird anomaly, which I'll talk a little bit more about here down the road. You can see it here. There's a little odd character. So pulling all this together, we've created a web-based application. This is using a Python Flask backend using JavaScript frontend. User interface allow for uploads of most typical image types. Once you upload the image, the models will locate the characters, identify what the character is, and sort them into lines. This can enable the user to produce diplomatic transcriptions. And we can also produce character alignments within the image. And at the end, we'll have a Unicode character transcription output that can be stored and saved for later. So for this demonstration here, we've chosen a section of a fragment from the Oxyrhynchus papyri. I've included the details over on the left in case anyone's interested. So I have a little video demonstration here, and I'll try to walk you through this. So this is basically set up right now as a web-based application where you can go and either on your computer or via a web service, we're not sure how this is going to go yet, and upload your image into the interface. And once it's uploaded, you're going to get the locations of all the characters on the image found by the model. And over here, we have a color code that tells you the confidence of the model as, so this is telling you how confident the model is that it found character. You can also add user created boxes. All the boxes can be reshaped and resized, relocated, however you want to do that. That can be done individually, or you can cycle through them one at a time for a less cluttered view. And you can also delete any of these boxes. So right here, we're just making one small correction. That tear is kind of confusing the model just a little bit. But once you're happy with the transcription here, the locations, then we move on to the line finding algorithm. And you can see the color coding here that shows you which characters belong to which line. We're planning to add the ability to alter those lines as well. Once you're ready and to move on, then we have this location overlay transcription where we actually have the Unicode characters shown in the location where they would be on the original image. And then we also have a Unicode text transcription output. We plan to have make these available for download. We also would like to do some kind of data file along with that, maybe a CSV file, so you can actually go back and look at all the information, the predictions, the confidence from both models, locations, put things in order. So here we have that transcription that I just shared with you, side by side with the original fragment. As you can see, it did pretty well. We didn't make all of the corrections intentionally, so we wanted to find some errors just to kind of look at how well we could do. One of the most interesting things we found was right here, with 2 towels together. I'm told this is not normal. And this character right here, this psi, is actually a correction. So we found it interesting that first it found that character because it's much smaller than the others, and that it associated it with the correct line. So some of the next steps we're talking about for this project. First off, we want to explore using larger and newer versions of YOLO. We're currently using YOLO versions 5 small. There's a large and an extra large version of YOLO, which we haven't used so far because of memory issues. It takes a lot of computing power to train those. And of course, YOLO version 8 just came out, I believe, in March of this year. So we're going to look at trying to adapt our approach to those models and see how well they do. We're also continuing work on the line finding methods. In the future, we really would like to add some natural language processing. We would like to be able to compare the fragment or the transcriptions to a corpus of text to determine what that character or what the fragment's from, what if it's a well-known. Want to get the terminology right, well-known transcripts. We also want to add the ability to detect missing characters or to predict if there's a gap, predict what character should most likely be there. We don't really know how this is going to be packaged up just yet. We're thinking either a web-based service or possibly just software for local machine, maybe an open source repository where you can just download this and set things up on your own computer. One of the most interesting things, because of the fact that this was crowdsourced from crowdsourced annotations, we feel like this pipeline should be able to be applied to virtually any language. We're not really sure how the segmentation model would do on some languages. Obviously, you have a lot of the Eastern Asian languages might be a little bit challenging to separate the symbols, but we do think that this could be applied to a broad range of languages. And it turns out it doesn't just work on papyrus images. We've actually tried it out on some images of some stone fragments. The segmentation model does really well at finding characters, but the classification model has a little bit of trouble with shadowing and depth, so it has a little hard time sometimes. And then we also, just for fun, gave it an image from the Dead Sea Scrolls. Even though it's trained on Greek, it still does a pretty good job at finding characters. So if you are interested in more information about the ALPub datasets, it's available on this website here. You can actually scan the QR code over there. My own personal website's here. There's some other related work on my website as well. And I apologize in advance. I have a little bit of hearing trouble, so I may have to come to you to hear your questions. If anybody has any.
Questions?
I'm wondering what you do binarization.
I'm sorry.
Binarization, like this is notoriously difficult for papyri because the example you showed, the contrast is pretty good, and a lot of papyri are really hard to deal with.
It's really interesting. When we first started working on this, we tried some binarization and tried converting everything to grayscale, tried several different things to denoise the images. We found we had worse results.
But I mean, have you tried any really hard papyri, the ones that don't have good contrast?
We have tried several, yes.
And
Actually got a hold of a scan of some Herculaneum from Vesuvius. There's a project where they're unrolling those. It actually does a pretty good job on those, even though the color scaling is completely different.
Yeah, and it works.
Yeah, that's one of the interesting things about the data set is they're not all the same. They're from various different digitization efforts. So some that are
scaling is
different.
Scaling is also a problem because
I'm sorry.
Scaling is also a problem in
Yes.
the future.
Yes, that's definitely something we haven't run into a lot on this, but we know that that's going to be a challenge. We're hoping to approach that with an iterative method. Since the YOLO runs just as fast as you saw it in the segmentation model. So we think if you run that several times at different scales, you might be able to find the method optimal.
Thank you.
What happens if it's an example where the scribe had an off date or something like that, where the handwriting is not as beautiful as that one?
Specifically, my guess is they would probably find a location, may not be able to screen the character as well.
And do you plan on handling that with the NLP pass that you want to do later?
I think that's probably our goal, is to have the confidence of the classification model is very low. That's when the NLP step in.
This project is awesome.
Did you include augmentation methods as well?
We actually did initially we tried using the Keras data generator augmentation, and actually found that it performed more poorly. It's very strange. One of the interesting things about the data set is if you look at some of them, they're just totally worthless images. They're really, really badly damaged. But we feel like what data augmentation does is actually replaced by those damaged examples. So it's almost kind of like the augmentation is built into the data set itself.
Would this system with YOLO be, could it adapt to three-dimensional imaging? If you wanted to say work with cuneiform tablets.
I think so.
Yeah.
I've been kind of thinking about that lately. I'm not sure if there is a three-dimensional equivalent to YOLO out there yet. If there isn't, there should be. And I would definitely like to work on that. You know, there's a big thing right now, the Vesuvius project. I don't know if anyone's familiar. But they basically have 3D scans of charred papyri from Vesuvius, and they have a challenge out there right now. They want teams that can go in and digitally unwrap those scrolls. So I'm sure they're going to have to come up with something along those lines to do that. Thank you.
I was wondering, did you try with cursive scripts as well?
There are some cursive in there actually. That was one of the challenges with the data set initially. It does surprisingly well at separating the cursive. Not always perfect. You get a lot of things like side-by-side tau versus a pi. It's confused quite often. The example I showed earlier that actually YOLO found the pi itself, then it found the left side and the right side and thought it was two taus, so it can show all of them. So it's one of the reasons we included the confidence colors in here, so that the darker the confidence color is, the less likely it is to be correct. So kind of that's one way to approach dealing with that person.
Thank you. It's really exciting.
Right, so we give another round of applause.